welcome to this edition of the FDTD Goes Our Applications. This presentation is given by Carl Jones from the Forecast Office in sunny Grand Forks, North Dakota. GOES 16 identification of blowing snow. And he's in control right now, so Carl can go to the next slide just to go over a couple of different things to remember. We're always looking for speakers. So if you have a topic on how your office might use GOES 16 or GOES 17 data, please contact either me, Scott Lindstrom, or Dan Bikos. The next slide, please. Just some ground rules, of course. It's about 20 minutes for the speaker. If you have questions, you can send them to the GoToChat. There are also questions afterwards. Will be about 20 minutes of listening to Carl's talk, and then maybe some questions after that. So we'll be done by 18:30 UTC. Don't press hold. And if you're not speaking, please press mute. I'm done speaking, so I'm going to put it on mute. Take it away, Carl, and thank you.
All right. Thank you, Dan and Scott. I've actually kind of always wanted to do one of these, so I appreciate the opportunity that you guys are giving me. And yeah, I'm really excited to go ahead and share with everyone some of the findings that we've found here in the office at Grand Forks about detecting blowing snow using GOES 16. It's each time it happens, you know, it's a really exciting thing that we're able to do, and it's something that we haven't been able to do in such a fashion previously in the previous generations of GOES and using polar orbiting satellites. So here in the office, we've found that using the day snow fog RGB has been the best way to kind of see this blowing snow signatures. And so we'll kind of break that down into its three components. Using the Veggie band and the red channel, we're able to see, you know, good contrast between the water and land surface characteristics, and then it also detects clouds as well. It's kind of like that visible imagery that we're also used to seeing. And then in the green component is the snow ice band, which is the 1.16 micrometer channel. And this is good for distinguishing the water phase, whether it's in clouds or snow on the ground or even lack of snow on the ground. And since it is a near-infrared band, it's also good for detecting the size of cloud particles or ice crystal shapes, and we'll find out that this is kind of an important channel that makes this capability more capable. And then lastly, in the blue component is the day fog difference, and this is also good for seeing the differences between ice-based clouds and water-based clouds, as well as since it has that reliance in the near-infrared or the shortwave infrared band, that 3.9 micrometer, it also can detect some cloud sizes and ice crystal size. And I like showing the Swedish Chef when talking about RGBs, because you're able to take all this information and kind of combine it into just one image. You know, we're looking at 4 different channels, information from 4 different channels, and combining it and looking at it in just one image. And before we start looking at imagery, we're going to start to give you, I'll give you an example as to when we first noticed this signature. That was January 11th of last year, and we had a pretty strong cold front, an Arctic cold front come through, and then we had some really strong pressure rises on the backside of that cold front, and that developed pretty strong northerly winds, low-level winds, and this went ahead and created some blizzard conditions, or at least what we were expecting, blizzard conditions. This type of setup is pretty typical for getting blizzard conditions within the Red River Valley, and you can see these blizzard warnings that were in effect during this morning. And just to kind of give you an idea as to what the Red River Valley is, because this is our main geographical feature within Grand Forks, it's a north to south oriented valley that straddles the border of eastern North Dakota and northwest Minnesota, and this has a tendency to funnel northerly winds, and even has a tendency to increase them, which can just be just enough of that push to go ahead and create significantly reduced visibility and blowing snow in general. So this this is what we started to see during the day on January 11th, just to kind of give you an idea as to what we're looking at in this RGB. The red color is snow on the ground, that deep red that you can actually see in eastern North Dakota. That's just snow on the ground. And then you can also see some clouds that's in the bluish-purplish color. They're low-level clouds. And you can also see some higher-level clouds further into Minnesota that have that red magenta color to it. But as these clouds started to pull away, we started to notice an additional cloud feature that was within the Red River Valley and where we were getting blowing snow reports, and we were expecting blizzard conditions. And it didn't take us very long to realize that we were actually seeing blowing snow. So we were able to quickly put this imagery to use in an operational setting to help refine our products, to help get a better idea as to where we're getting some really impactful blowing snow. And we used our knowledge of antecedent conditions. Just the night prior, we had a fresh snowpack of around 6 to 8 inches in the central portion of the valley. And with that knowledge combined with the surface observations that we were getting, and we were also looking at webcams pretty much throughout the area, and you can kind of see this west to east progression of rapidly reducing visibilities the deeper you got into the eastern central portion of the Red River Valley. And we were able to really refine those blizzard warnings from the top left image, encompassing the entire Red River Valley, to down just to the east central portion of the Red River Valley. So that was really exciting to see that happen. And then just 4 days later, we happened to see the same signature. This is your kind of typical ground blizzard type scenario. We didn't really have a whole lot of clouds, nor did we have any precipitating clouds that created snow, falling snow, to help reduce visibility. This is strictly just from the winds funneling down the Red River Valley, and we can see that blowing snow feature, that cloud feature, moving in the same orientation of the low-level flow. So we were able, that was kind of like, that's it. We were able to see blowing snow using this approach. And the blowing snow typically shows up in a pinkish salmon color and sometimes even an orange rust color. And there was also just happened to be a lucky Landsat 8 pass during that day. And down to 15 meters in resolution, we were really able to see how tightly packed that blowing snow really is. It's really tightly packed horizontal convective rolls or cloud streaks. And each of these rolls they're kind of on the order of around 1 mile in length from east to west, and they can be even tens, maybe even hundreds of miles long meridionally. And also kind of shows that it has some billowing nature. There is actually some depth within this blowing snow. And that'll be kind of important going on later on. We'll kind of see why that's important, this billowing nature and the height of blowing snow. Breaking down each of the components of the day snow fog, you can see at the top right, the veggie band. There's not really a whole lot of contrast between the stratus that you'll be seeing that precedes the blowing snow. The stratus compared to snow on the ground and even the blowing snow signature, it all kind of shows up just white generally. However, if we look at the snow ice band, we can see that there is pretty good contrast between the stratus ahead of the blowing snow, snow from the ground, which is darker, and then we're even seeing some signature of that blowing snow showing up. That shows up just a little bit brighter, I guess, compared to the snow on the ground. And then we're even seeing that same contrast in the day fog difference, where the pretty stark contrast between the stratus that comes through and the snow on the ground. We're even seeing that blowing snow signature show up just a little bit brighter in that channel. So combining all three of these, you can really see that we're getting added input and we're being able to see the blowing snow, mainly from the snow ice band with and even the day fog difference. Those are the main two contributors to why we're able to see blowing snow in this RGB. And sometimes, so being in the higher latitudes in the winter months, we don't really have a whole lot of light to work with, and sometimes it's kind of hard to see this blowing snow signatures when you're in those low light environments, particularly near dawn and dusk, and again in the higher latitudes in the winter. So we've kind of found that shortening the ranges of each of these composite ranges, the red component, the green, the blue components, you can actually kind of squeeze out the color and squeeze out some contrast to help bring out those signatures. So if you happen to find yourself really trying to struggle to look for some blowing snow, this might be a good first place to look, to try to help squeeze out that signature. So here's a case where we were able to see some light reductions in visibility, but we were still able to clearly see blowing snow. You can see those blowing snow streaks coming down the valley, but we were only getting observations and reductions of visibility. I think the lowest I found was 7 miles, so they really weren't too impactful yet. We were still clearly seeing these signatures, and we were able to see this particularly near the evening hours and the sunset hours, or closer to sunset, and that has a lot to do with the billowing nature of this blowing snow, casting shadows to really help kind of bring out some contrast between the shadows and the actual blowing snow itself. And in this image, it also shows the limitations as to using this approach. First, the limitation of masking clouds. Since we're looking at it from the top down, you can't have any higher clouds move over your blowing snow signatures. And then towards the end of the loop, since we're relying on, there's so much reliance on near infrared, you have to have it during the daytime hours. They added, or I guess the reliance on the solar reflectance in the near infrared kind of really limits us to only using this during the daytime. So here's another case where it makes things kind of complicated because you can get some snow showers in a cold, arid, vection-driven environment. This environment is pretty similar to when you could get some blowing snow. However, you start to see kind of a more added component from the day fog difference. That is, you start to see like a little bit more whitish, blue-purple color in the actual cloud streaks themselves, as opposed to the blowing snow. And you can really see that develop towards the end of the loop in the afternoon hours in northern Minnesota and southern Canada. And sometimes it makes it a little bit more easier where you can actually see there is a clear difference between what is blowing snow and what is snow shower. And you can start to see this blowing snow signature develop out of southern Manitoba and then start to advect into the northern Red River Valley and northwestern Minnesota. And this has that orange rust color that I kind of mentioned before, and it makes it a clear difference between the clouds and the snow showers that you're seeing in further towards the arrowhead of Minnesota. And that's another one of the things that we've kind of learned as well. Using this imagery, you can start to find out if maybe advecting blowing snow might pose an impact to your CWA. This is from the 24th of last month, where we were having some overnight blizzard conditions for a pretty good portion of the eastern Dakotas and into western Minnesota. And this blowing snow, it did linger through the next day, but you could really see it start to move from southern Minnesota and into northern Iowa. And you can really start to see it towards the end of the loop right there as you start to get that those billowing shadows to help bring out the contrast with that as well. And so with using that type of approach, and you're able to kind of treat this like a convective scenario with the approach of using satellite imagery and using surface observations from ASOS and AWOS, as well as looking around from cameras around the area. These snowplow cameras, if you're lucky enough to have them in your CWA, have really been pretty awesome to see what's exactly happening underneath these streaks, these blowing snow that we're seeing on satellite. And of course, using reports and sometimes even radar can help depict, when you're starting to get some blowing snow. We're able to use this all in conjunction with itself to make winter products that may seem typically more long fuse. You can kind of make them a little bit shorter fuse because we're getting this in more real time with the rapid updates that the GOES-R series kind of provides. And we're also able to kind of localize our winter products just a little bit more. And again, you kind of just treat it like that convective scenario. So here's an example from the Arctic air outbreak that we had on the 29th of last month. There was a pretty large area of blowing snow that showed up, especially towards the later portion of the loop from the eastern Dakotas, a good portion of Minnesota, northern Iowa, and even into northern Illinois, and even into northern Indiana. And if we kind of focus in on northern Illinois, we can start to see this blowing snow signature start to show up after 11 a.m. and noon. And then as these streaks started to develop, you can focus your eyes towards Freeport and Rockford. Right when one of those streaks moves over those observation sites, visibilities went down, and even Rockford Airport reported blowing snow right as that streak kind of moved over. And that same kind of scenario happened with other areas, observation sites around the area, but you can really see that happen during the Freeport and Rockford airports. And while I was trying to find other cases around the U.S. Where this signature might be showing up, so it's not just Northern Plains centric, found an interesting case where we were seeing this signature show up that came out of a lake effect band, or lake effect bands coming off of Lake Huron, moving over the thumb of Lower Peninsula of Michigan. Now, it's hard to say whether reductions in visibility in this location was exactly from or solely from blowing snow, if there was still some actual precipitating snow. But if you kind of see at the camera towards the bottom, there was some pretty severe reductions in visibility at times, right as these signatures moved over its location. So kind of going over the advantages and disadvantages for using the day snow fog RGB to monitor blowing snow. The main advantage is that you're able to easily monitor blowing snow in real time in a way that we haven't been able to previously. And not only can you detect light reductions all the way to blizzard conditions and reductions of visibility, it can detect that whole wide range of blowing snow. You can put this to use in an operational stance. When used appropriately, it can help refine your products and even your messaging. And again, some of the disadvantages is that using the day snow fog RGB with its with its reliance on the near infrared, you can only use it during the daytime. And since we are looking at it from top to bottom, you can't have any higher clouds masking the blowing snow. And while we're able to see this wide range of blowing snow and how severe it is, it doesn't explicitly tell you how severely reduced the visibility may be. Just because you're seeing this image on satellite doesn't mean that you're getting blizzard conditions under it. So why are we able to see blowing snow? Still don't know exactly why, but the running hypothesis, after kind of talking with some other scientists in the field, is that as you start to shatter your ice crystals in this high wind environment, the population of the very small ice crystals grows, and as they're suspended into the air, this leads to a higher reflectance into the 1.61 micrometer channel, and even perhaps even into the 3.9 micrometer channel. And that really helps bring out the contrast when you're comparing it to the surrounding snow on the ground and the wafted snow. So that kind of brings, to mind, like, while the snow ice band is typically thought of detecting differences in water phase, this particular detection of blowing snow is not likely a result of the phase change, but rather a detection in the differing cloud particle sizes, or in the ice crystal sizes. And there's also the added component of us being able to see blowing snow in the day fog difference products, and we're still not exactly sure why we're able to see it here. Is it because the billowing blowing snow is able to acquire colder temperatures closer to the top of the boundary layer? Is it because of that reliance on the 3.9 micrometer near infrared channel, which has a dependence on or can detect the particle size distribution, or even if there's phase changing going on towards the top of the boundary layer, towards the top of these blowing snow billows. I mean, there's not a whole lot of research that involves blowing snow, so can't necessarily throw that out. So just kind of wrapping it up, here's some conclusions. Again, you're able to effectively monitor blowing snow in real time and able to easily see blowing snow using the day snow fog RGB. You can detect this wide range of light reductions in visibility under these blowing snow signatures, and it can be used operationally to refine products and messaging. And it's using this approach, it is meant to supplement your traditional in-situ observations and your understanding of the environment. And you can use surface observations, reports, webcams, and radar in conjunction with this day snow fog RGB, almost like you would kind of treat a convective scenario. And we've also found that during low light environments, say in the early morning or towards the late afternoon or winter months, if you're in the higher latitudes, you can shorten the RGB composite ranges to help draw out features of the blowing snow features just a little bit better. And as with most things, it has limitations. You can only use this during the daytime. It can't have any masking clouds on top. And lastly, there's still some research that needs to be done as to why exactly we're able to see blowing snow. And with that, I will open it up to questions and comments.
Okay, thanks. Does anyone? I don't see any questions in the YouTube. In the GoTo.
Hey, this is Ed in Boulder. I did put one in there. I'm not sure why you don't see it, but
I'm not in control. Dan is.
Oh, or Dan. But I can ask it.
Sure.
Hey, Carl, that was a really, really good presentation. We have looked a little bit at this too. We have a product that scientist at Sierra has developed, a snow cloud discriminator, and wasn't intended to look at blowing snow, but we thought we saw some signal one time. It is ready for ARIPS if anybody is interested, and we'd love to have people try it out. But my question for you was, when I looked at some of those loops, and you had some great time-lapse in there as well, it looked like sometimes there were clouds, and then I noticed some of the OBS were suggesting clouds. Mm-hmm. How sure are you that some of this isn't cloud we're seeing in, low cloud, or what do you think?
I would say not very sure. So some of the things that we've actually had a recent event where outside of the valley there was getting really severe reductions in visibility from blowing snow, and it's almost as if the blowing snow passed right over the valley, and it just looked like a low-lying cloud. We weren't getting any reductions in visibility here in the lower elevations. So it kind of made us start to think, well, is this, can you actually have the blowing snow lofted so far up where you're not getting any sort of impact towards the surface? And again, what's happening towards the top of these plumes? Can you actually grow cloud, or are there any cloud developing processes? At first, we started to think that's maybe where the day fog difference kind of helped clear out. You started to see a little bit wider color, I guess. That added value from the day fog difference started to help differentiate. This is cloud and this is blowing snow, but we've had some pretty recent cases where that might not be the case. One in particular being the cold air outbreak. Here, I'll actually go back real quick to that. And towards later into the loop, you kind of noticed within northern Minnesota, you start to see that wider purple color, the added component from the day fog difference. And we knew that there was blowing snow. We didn't necessarily believe that there was any water in there. It could have been a phase change, but this might just have been a result of the extremely cold environment with this reliance of the thermal characteristics of this particular air mass. So I guess to answer your question, no, I'm not very confident as to what exactly is cloud and what is blowing snow. But if it's reducing visibility, it might not be too much of a difference.
I think we'll try to take a look at some of these more recent cases a little bit more. That's really fascinating stuff.
Yeah, thanks for the question.
Yeah, hi, Carl. This is Bernie from Fort Collins. And so, with regards to your recent Arctic case, refresh my memory, were the temperatures during the day at cloud level around, like, say, minus 30 or minus 40?
They were around negative 20 to negative 30. So they were quite cold, and could start to see. We were definitely getting into those temperatures where they mimic what the typical cloud temperatures that you would see, or cloud top temperatures.
Okay.
So this was kind of an outlier case, but I could not, not show it just because of how expansive the blowing was.
That might be affecting the colors a little differently too, because
Right.
in the 3.9, you're starting to get to where it's cold enough to introduce a little bit of noise. So
Right.
yeah, but I think your point about just reducing visibilities and whether it's cloud or not is a very important one. So stepping back and recognizing that, hey, this might not happen all the time, but it's very helpful to what we're doing. So I think that's great. And thanks for your presentation.
Thank you.
Are there any other questions?
And if you have any further questions, you can contact me.
This is Doug up at Anchorage. We were just wondering, real quickly, what the green color over Nebraska represents in this imagery, most of this imagery?
There was no snow on the ground there.
Oh, it's bare ground. Okay. Cool. Thanks for clarifying.
Thank you. Thanks for the question.
If there are no further questions on this, this is an opportunity to ask any Go 16 or Go 17 questions. I assume you've all heard that Go 17 does go operational next week sometime between Monday and Friday. I don't know if Brian's on the line or not, if he wants to add anything to that.
Yes, Scott, I'm here. The 17th is the working date, but could be impacted by any number of things, including possible shutdown or critical weather days, that kind of thing. So, tentatively the 17th.
And if there are no further questions, I'd like to really thank Carl for this presentation. I really